Hello guys, welcome back to Quadratic Functions, and we continue exploring transformations. So transformations, it comes from transformation theory, and you probably remember how to transform different objects and apply different types of transformations. So probably you remember how to cope with triangles with like different 2D shapes, how to transform them. And today you need to be familiar how to translate and how to transform functions. So we consider scale up and scale down transformations. Simply in terms of quadratic function means that if you have standard basic quadratic function y from x equals x squared, you need to find out how it can become y star, like sort of new function that made of the previous one multiplying by a. So simply you have a times x squared, where a squared is simply your previous standard function y from x. So we have the following sort of transformation: a times y from x, okay, where y from x is basic parabola x squared. Okay, so for simplicity, I'll just give you an example and we start exploring function y equals x squared. That's your basic one. And let's apply transformation of scaling with the coefficient a equals 2. So in this case, we have new function y star. I simply use star notation in order to differ y star from y, your basic parabola. And we'll get 2 times x squared. Alright, so in order to compare what actually happened to the graph, we need to set up the table, and this is the best way how you can compare. So we set up the table for x, y values. So I guess let's get we set up right here. So we take x, we take y, and we take y star. Okay, and let's just line values up, and we start running from, let's say, -2, -1 to 0, and from 0, 1, 2, and that's pretty enough. Okay, so now it's time to figure out the values for y. Because y is simply x squared, we just put all x instead of x squared, and instead of x and raised to the power of 2, and calculate y for basic parabola. So first we start calculating for basic function, which is basic parabola. Okay, so -2 squared is simply 4, -1 squared is 1, 0 stays 0, and then we have repeating value. Just remember, the parabola y equals x squared, the basic parabola, has the symmetry, the line of symmetry that goes through x equals 0 and vertical. So basically y-axis becomes axis of symmetry for this parabola, and you actually see that when x equals 0 to the right and to the left hand side of 0, you have matching y's for positive and for the same but negative values for x. Okay, so I'll use red in order to depict my basic parabola. So we'll get, when 0, we have 0, it's here. When you have positive 1, you'll get y equals 1 as well, so it's here. And then you have also 2 for x and 4 for y. So that's the point. Okay, and then we smoothly connect all the points in order to get our parabola. So this sort of graph that represent basic parabola. So you can mark y equals x squared on the graph. So the left hand side actually will be mirrored according to the values that we have. For -1, we also have 1, so it's simply here, and for -2, we also have 4. So that's why it's going to be like simply reflected along y-axis, and the right hand side will just repeat the left hand side of the graph, part of the graph. Okay, so let's say we've done with the basic parabola y equals x squared, and now we choose another color and just calculate the values for y star. So they simply double more than the basic function x squared, so we can use the phone because double more we can take y values and multiply by 2. So we'll get 8, 2 times 1 is 2, 0 stays 0, and again 2, 8, we just repeat the values. So obviously you see that for 1, when you have 0, 0, okay, that's matching point, but when we have x1 or -1, the previous value were also 1 and 1. However, for new y star function, you'll get 2. So that means for y, for y star, you'll get different points, and if you start connecting them, you understand that you have a shrink of the parabola, so it gets narrow. Okay, that's the first outcome that you might notice. Okay, so for 4, when we have for y previous function, it's here, those points. Now for y star, instead of 4, we'll get 8. That's for x equals -2 and 2. Okay, so we take 2 and -2, and instead of 4, we just rise pretty high. So that's for 2, so obviously here. And for -2, it's somewhere around here, okay? And now we need to connect those points with the previous ones. So it goes something like this. So it gets definitely narrow than your original graph. Okay, so we just go upwards, and what we notice that the parabola gets narrow. So in other words, it shrinks. It shrinks horizontally. So it's horizontal shrink. So it gets narrow horizontally. So that means the general idea or general outcome, if we have function y multiplied by some a, and you take in the basic function x squared, and no matter, actually it can be applicable to any sort of function, to straight lines, to quadratic, to cubic, to trigonometric functions, no matter. When we apply a as the scale factor, in this case it's called scale factor, and if a is more than 1, okay, we explore the case when a is more than 1, we understand that your graph or your function, so your graph is better to explain from the graph point of view. So your graph, new graph, shrinks or gets narrow horizontally. Okay, so it shrinks horizontally. So it means that your actually branches for quadratic function gets narrow in comparison with the previous. Well, why is called scale, like scale up or scale down? In this case, we consider as scale up because look at what happens to the values of the function. When we took x equals 1, there was original basic function y equals also 1. So when we take x equals 1 for like basic function y equals x squared, we have also 1. But now let's see what happened to new function. All the values were doubled, and in this case we'll get not 1 but 2 times more. So that's why you can consider, not graphically, but algebraically, by applying scale factor a, and if the scale factor is more than 1, we simply have multiplication by a all the previous values, and if it's more than 1, we understand that all values raised by some like number, which is a in this case. Okay, in our case a was 2, so all values for the previous y function raised by 2 times more. Okay, instead of 4 we'll get 8, instead of 1 we'll get 2, instead of 0 is not changing because no matter which number you multiply by 0 you still have 0. Okay, so that's why your a is called a scale factor. In case a more than 1 we have scale up. Okay, let's just briefly consider what if a is a fractional number. It's still more than 0 but it's less than 1. Let's say a equals 1 over 2. So let's consider a new function y star, which is 1 over 2 of x squared. So what will happen? All the values obviously will be divided by 2, or if you apply coefficient 1 over 2, that's the same as you saying that you take your x squared values and you simply divide by 2. So if we create a table for let's say it's better maybe marked as not y star but maybe g. Okay, just let's use another g function. So we set up here in the value tables and we simply need to take all previous values for y and simply divide by 2. Okay, so 4 over 2 is 2, 1 over 2 here 0, and again we just repeat 1 over 2 and 2. Okay, so all previous values for standard basic parabola were simply divided by 2. That's why in case if your a is within the range 0, 1, so no matter which fraction might be within this range, actually in this case, so you have a scale down. So all the values for a new function becomes 8 times, so in this case if a is a fraction, so that's why 1 over 2, so 2 times more, 2 times less in this case. However, what will happen to the parabola graphically? So I'll use green color for that and just let's try to depict all the values, but just trying to make a sketch of that. Okay, so we got 2, 1 over 2 and 0. So we simply, instead of values of the previous function 1 and 4, we'll get 1 over 2, so 2 times less, and instead of 4 we'll get 2. So let's write for x equals 1, instead of 1 we'll have 1 over 2, it's here, and instead of when x is 2, instead of 4 we'll simply get 2. Okay, as you might expect, the parabola gets wider. It's not shrinking anymore, it gets wider. So the left hand side part of the graph is going to be also widened. Oops. Okay, so it also gets wider because it symmetrically needs to repeat the operation from like for the right part of the graph and just carry it to the left hand side of the graph. Okay, so we have generally for a from 0 to 1 we have a scale down. It means that we actually diminish the values for the function, but graphically it gets wider. So you can memorize actually scale down means gets wider. That's, you may say that this is horizontal stretch, in other words, so that's horizontal stretch, and that's horizontal shrinks, right? You may memorize, you can do that, so you can memorize what will happen to the graph if a is like fractional number, if a is more than 1. But I just recommend to set up the table or even like create algebraic writings, how to connect your new values for your new function with the previous, and you obviously see what will happen graphically. So there is no problem to restore points from, let's say, this data table if you have comparison with the previous value y, and you can easily restore g, which is 1 over 2y. So no problem for that. So it's about like how you, mostly it's about how you understand what will happen. So algebraically and graphically you can always do that. So you can simply, if you're not able, so probably within like months you probably lost the idea what will happen. So the hint here and the tips what you can do, you just simply can test the data table. You need to set up the data table for your x and compare your previous y values with the new values of the new function, and you understand what will happen actually graphically. That's the best way, and this is the shortcut for you guys, so that not memorizing a lot but better understand more. Okay, but let's consider the last case when a is negative. So what if a is negative? So negative. Let's consider again, we set up the data table. So I just set up quickly for y equals x squared. When x runs through -2, the step 1 to 2. So here I'll just give an idea what will happen. So x squared, so 4, 1, 0, 1, 4 symmetrically. Okay, and we have, let's say, a equals -1. Let's say what will happen in this case. We'll have minus x squared for a new function y star. So simply, we just put the minus before the values. Okay, -4, -1, 0, and again -1 and -4. So what will happen? Instead of positive values, they have the same but however negative values. In this case, I'll use, let's say, this purple one. And for using the purple color, I just briefly drop the points -4, -1, 0, -1, -4 for all previous values for x. So that's why you can imagine that you taking the red graph, that's your x squared, and simply reflect along x-axis, along the horizontal x-axis, just down. So it looks like it goes this way because it's simply reflected along x-axis. So there is nothing happening because a is just -1. If it were like -2, -3, because you need to put a minus and you need to multiply also by values that you have. For example, let's consider -2. So in this case, if you consider what will happen to your original values, so they were multiplied by -2. So y, let's say double star, new function, which is -2x squared. So let's see what will happen. You just simply need to times by -2 all the values that you have here. So you'll get -8, -2, 0, -2, and -8 again. So obviously that also the branches will be downwards, yes, in comparison with the previous case when we have normal basic parabola, the branch is upwards. Now it's flipped because it's reflected along x direction, along x-axis, and now your values gets higher 2 times more basically, however negative. So that's again from transformation theory. So you get narrow of your graph, that's basically will be blue one, and just reflected along x-axis downward. So you'll have something as purple but narrow, so something like this. So simply you'll have reflection for your blue graph but downwards. Okay, that's what will happen. So basically when a is negative, so you will have reflection of your basic graph, of your basic parabola y equals x squared along x-axis. Okay, that will happen to your graph. Okay, so we considered how apply transformation of scale up and scale down. In the next video I'll show you how to simply translate your parabola or your basic function horizontally and vertically, and in combination, like when you have double transformation, you have vertical shift and you have horizontal shift simultaneously, and we'll see what will happen to the graph. And finally we explore what will happen generally when you have scale up or scale down in combination with translations. So guys, get ready for next video. Hope you understand that in detail. So I intentionally gave lots of details so that you can understand what actually happens and how to apply a coefficient or a scale factor to the functions. So just try to carry the idea from transformation theory for objects onto the functions, and you understand that it works pretty the same. So but unfortunately you actually didn't do anything with, so actually yes you did, because for example, if you apply scaling factor, you notice that each side were increasing or decreasing by a scale factor. Okay, this is the same because your scale factor a works in a similar manner. Okay, hope you enjoy, guys. Don't forget to subscribe and share your ideas about the prospective videos. Probably we need to change the format, so you guys need to say me whether we need to do that or if it's okay, so we just keep going and keep working. See you guys.